Welcome to PetroBarrel. Today we will unlock the secrets of Reservoir Rock Properties step by step, which is the foundation of every reservoir engineer's knowledge. So let's get started by the first topic, which is the meaning of porosity of the reservoir and its types, referring to the geological classification and engineering classifications. So based on introduction of the porosity by definition, we have porosity, which is the ratio of the pore volume divided by the bulk volume or total volume. Let's imagine that we have a sponge, and inside this sponge we have a lot of holes or a lot of pores. So these pores very similar to the pore spaces located in the reservoir rock. And also I have the material of the sponge, which has yellow color, referring to the mineral grains of the formation or the reservoir rock. So here we have three volumes. The pore spaces volume, which is this volume, which has light blue color. Bulk volume, which is the total volume of this square. And I have matrix volume, which is the volume of the mineral grains, which has gray color. So based on the rule or the equation of the porosity, which is equal to the pore space volume divided by the bulk volume or total volume. And also I have the pore space volume equal to the bulk volume minus matrix volume. Why? Because simply I know that the bulk volume is the total volume, which is equal to the pore space volume and the matrix volume. Referring to the range of the porosity, the conventional range of the porosity from 5% to 40%, but it depends on the type of the formation. If I'm talking about loosely consolidated sands, so we have high porous formation. So we have range from 35 to 40%. Sandstones, we are from 20 to 35. Well-cemented sandstones, we have porosity range from 15 to 20, referring to the limestones from 5 to 20, and according to the dolomite, we have a porosity range from 0.48 to 4.85%. There is another important tip in this slide, okay, that the normal range of the porosity doesn't exceed 40%. For example, if I'm talking to you that we have porosity in this reservoir 80% by calculations, so I'm wrong 100%. We doesn't have any value of the porosity very high, like 80% or 90%. This is impossible. But referring to the conventional or the normal range of the reservoir rock properties, okay, we have porosity from 5% to 40%. And also referring to the geological classification, we have primary porosity and secondary porosity. The primary porosity is the original porosity that develops during the deposition of the sediments or of the material. It includes the formation of sedimentary rocks, which has four main stages, which is erosion and transportation of the sediments. For example, if I have sediments located on the land, due to the wind and the movement and erosion and transportation, we have a lot of sediments located at the bottom of the water. So based on this stage, we move through the second stage, which is the deposition of the sediments, at which I have formation number one, then the deposition of another formation, then another formation, and so on, till reaching to the stage number three, which is the compaction, at which, due to overburden stress or due to high weight of the formation, we have compaction stage of the formation of sedimentary rocks. Then finally the cementation stage, which is salt crystals glue the layers to form more compact sedimentary rocks. As we will discuss later, inshallah, the meaning of cementing material of the sedimentary rocks. But here I'm talking about the original porosity. So this is the primary porosity based on the geological classification at which this porosity develops during the deposition of the sediments or the original porosity due to the formation of sedimentary rocks. Let's move on. The types, to be specific, the types of the primary porosity, it classified into two main types: intergranular, which is the porosity between grains. As you see, I have a lot of pore spaces behind the matrix or behind the grains of the formation. So this is intergranular. Okay. On the other hand, I have intragranular porosity, which is the porosity but within grain. I have pore spaces inside the matrix itself. So this is the intragranular porosity. And those types referring to the primary porosity based on the geological classification. Based on the secondary porosity, which is the induced porosity that developed after deposition by the geological processes like faults, uplifting, vux, fractures, and so on. So this is porosity, but it created after the formation of sedimentary rocks. So this is induced porosity, okay? As you see here, we have, for example, a sedimentary rock, and after 1,000 years, we have fault inside this formation. Okay, so this fault it created secondary porosity. Referring to the uplifting, I have a formation at a certain depth. So based on the uplifting process, this formation, for example, become or moving upward to become, for example, at 6,000 feet, but the original depth 8,000 feet. So based on this uplifting, we created secondary porosity, for example. And finally, vux and fractures also classified as secondary porosity, referring to the induced porosity that developed after the deposition or after the formation of sedimentary rocks. And finally, based on the engineering classification, we have total porosity, effective porosity, and isolated porosity. As you see in this figure, we have effective porosity, we have isolated porosity, and we have total porosity. So let's imagine that we have pore spaces which has white color, we have matrix which has gray color, and I have in the effective porosity or effective pore spaces, I don't see any obstacles inside these pore spaces. So it called effective because the movement of fluid, either hydrocarbon, oil, water, gas, any fluid located in the pore spaces, it has the ability to move through these pore spaces and coming into this, for example, this path, then moving here to reaching to the outside or moving or coming out from this formation and moving through another formation and so on. So this is called effective porosity. But the isolated porosity, I have pore spaces, but this pore space doesn't have any path for coming out the fluid through it. So this is the isolated porosity. Okay. For example, conventionally, if I have any hydrocarbon here, I don't have any option to produce this hydrocarbon conventionally. Okay, to be honest. Okay, so this is the isolated porosity. The summation of effective and isolated, which is the total porosity. For example, I have effective porosity 25%, isolated porosity 5%, so the total porosity equal to 30%. Also, I have another classification at which the total pore space equal or classified into two main types: isolated pore space. As you see here, this is the isolated porosity, by the way, at which if I have any hydrocarbon or any fluid located here, I don't have any option to produce this fluid conventionally. Okay. And the second type or the second classification of the total pore space, which is the effective pore space, it classified into another two types: dead end pore space, at which this end is dead. Why dead? Because the fluid doesn't have any option for overcome or moving through this end or this pore space. So it called dead end pore due to the impossibility of movement of the fluid through this way. Okay, and based on the permeable pore space, this is the most important type of the pore spaces because it is permeable, at which the fluid have the ability to move through this pore space from the inlet to reaching to the outlet. Okay, so this is the meaning of the permeable pore space. And we, as a reservoir engineers, we focus on the effective porosity or permeable pore spaces because it helped me a lot for increasing the production or facilitate the mobility inside the reservoir, or it helped me for the movement of the hydrocarbon inside the reservoir. Okay, as we will talk inshallah later, referring to the types of permeability and what is the meaning of mobility and so on, referring to the important terms of the reservoir engineering. So based on the definition, the total porosity is the total pore space divided by the bulk volume, and the effective pore space, it is the interconnected pore volume, which is this pore volume divided by the bulk volume. So this is the effective value. So we, as a reservoir engineer, we focus on this value, phi E, which is the effective porosity. Okay, so based on the equation, we have total porosity equal to the pore volume, but total pore volume divided by the bulk volume, and the effective porosity equal to the interconnected pore volume divided by bulk volume. So this is all about this video. I hope this video useful for you. If you have any question, please write me in a comment. And thank you, and assalamu alaikum wa rahmatullahi wa barakatuh.